This is part 3 of the video for the AP Calculus AB test number 4, covering position, velocity, acceleration, implicit differentiation, and related rates. These are the last two questions. So in number 16 we have a balloon in the shape of a sphere is inflated. The volume is increasing at a rate of 3 cubic inches per second. Again, I know that's dV dt just by looking at the units, because it's inches cubed that has to be volume, per second has to be your rate. So dV over dt equals 3. When r equals 2, what is the rate at which the radius is increasing? Okay, so we have the equation here, v equals 4/3 pi r cubed. We take the derivative of v and get dV dt. Then the derivative of 4/3 pi r cubed, we multiply by the 3, subtract 1 from the exponent, and put dr over dt. So we're trying to find dr dt because it says what is the rate at which the radius is increasing. That's what we're trying to find, is dr dt. So we plug in the 3 they gave us for dV dt, and we plug in the radius they gave us, which is 2, and then we'll solve for dr dt. Okay, 2 squared is 4, 4 times 4 is 16. Then I divide both sides by 16 pi. We get 3 over 16 pi, which is approximately 0.0597. So if you have, or 0.060, I guess if we round it to 3 decimal places. So if you have that, you're on the right track. Okay, 15 and 17 are probably the two toughest ones on these sheets. I'm going to try to go through this very carefully so you understand it. So we're told that candy is falling off a conveyor belt onto a conical pile at a rate of 15 cubic inches per minute. So immediately I know my dV dt. And that's 15. The diameter of the base of the cone is approximately 3 times the height. So d is equal to 3h. The diameter is equal to 3 times the height. When the height is 20 feet, what is the rate at which the height is increasing? So they want to know dh over dt. That's our goal. The equation for a cone is pi thirds r squared h, or 1/3 pi r squared h. Now that's going to require the product rule, so I will quickly do that over here. F equals pi over 3 r squared, g equals h. So f prime will be 2 pi over 3 r dr over dt, and g prime will be dh over dt. F prime times g is 2 pi over 3 rh dr over dt plus pi thirds r squared dh over dt, and all that will be equal to dV dt, because the derivative of v is just dV dt. Remember, at any point you're slow, you're behind me, feel free to pause the video and you can catch up. Okay, so let's plug in what they gave us. They gave us dV dt, that's 15, so that's going to go right here. 2 pi over 3 is just a constant. They didn't give us the radius, so let's pause on that. H is 20. We don't know dr dt at the moment. Again, we don't know the radius yet. And dh dt is what we're trying to find. So what we're missing right now are the r, the dr dt, and then, well, that's still the r. So we're looking for the r and the dr dt. Well, here's a good strategy for you. Sometimes problems give you information you don't need, but that's not usually the case. It does happen, but that's not usually the case. So we've already used this piece of information, and we've used, and this piece of information. The height is 20. So the only piece of information we haven't used is that d equals 3h. The diameter is equal to 3 times the height. Well, we need information about the radius, and they gave us information about the diameter. We know that the diameter is equal to twice the radius. So instead of saying the diameter is equal to 3 times the height, let's say that twice the radius is equal to 3 times the height. Now r, if we divide both sides by 2, is the same as 3 halves h. So that's easy enough. We can figure out r now because we know our height is 20. So 3 halves times 20. And we get 30 for our radius. So we can go ahead and plug in 30 for the radius. But we still need dr over dt. Well, if you have an equation with r, to get dr dt, you just take the derivative. Well, we have an equation with r right here. So we take the derivative of it, we get dr over dt equals 3 halves dh over dt. So we can't figure out a numerical answer for dr dt, but we can put it in terms of dh dt. So dr dt is 3 halves times dh dt. So now we can go about solving this equation. So we're going to combine some like terms. Let's see, 2 pi over 3 times 30 times 20 times 3 halves gives us 600 pi. So we have 15 equals 600 pi dh dt plus 30 squared times pi over 3 is 300 pi. So we can combine those and get 15 is equal to 900 pi dh over dt. So we end up with an answer of 15 over 900 pi, or about 0.005305. It's fine to just round to 3 decimal places, so you can put 0.005, and that's completely fine. But that is our dh dt. If you're still not sure about it, I'd encourage you to just back up the video a little bit, go through it again. You do have to use a relationship between the radius and the height in order to solve this one.